Thanks for joining for today's webinar. My name is Christian Henke. I'm the Director of Product, and I'm very glad to have a guest host, Paulo, Chief Technology Officer from Clarity. And
Hi,
today,
Christian.
hey, Paulo. And today we're going to talk about strategies for growth in IoT-enabled air quality sensing. So I'm really curious to see what Clarity does, what impact it has, and to learn more about the technology and learn how this can be applied in other scenarios. Paulo, maybe in the beginning you could give us a short overview about Clarity.
Of course. First of all, let me thank you, Christian and Amnify, for having us as guests. All right, let me briefly introduce Clarity. We founded Clarity now almost 10 years ago with the mission of empowering the world to fight air pollution. And for this reason, since the beginning, we decided to serve and to work with those organizations that we believe can actually take action and have their hands on the knobs and take action that can reduce air pollution. These are government agencies, municipalities, uh, industrial facilities, community groups, NGOs, and research institutes. So these are our customers. And as you know, air pollution is a global health issue. 7 million deaths annually are accounted to high pollution levels. And our founding thesis of Clarity is that if you cannot measure the problem, you cannot fix it. And today, in terms of measurement, we are faced with a challenge, especially for air quality monitoring. The traditional way of measuring pollution is outdated. It's based on expensive and bulky technology. You see here on the slide, there is this container-sized shelters that are basically field laboratories that are filled with expensive equipment, and they are expensive to install and to operate. And the result of this is that there is very few monitoring sites. Major cities with millions of people have maybe 2, 3 sites, and many cities have none at all, especially in developing countries. And our vision is for a world where each city monitors air quality at a very high spatial resolution with many monitoring sites, providing us with data that can lead to action and improvement of air quality. So let's see how we try to make this vision a reality. Is with our solution, we call it Sensing as a Service. It's composed of 3 main components, parts. The first is our IoT sensor, the Clarity Node S. It's easy to install and it measures pollution. And then the second part of our solution is our Clarity Cloud. It's a cloud data platform that is responsible for IoT device management on the field, but also data quality assurance and calibration, and data visualization, analysis, download, and integration with other systems. And finally, a very important part is our remote quality expert support to help organizations structure and run this new generation of quality monitoring projects. So these are Sensing as a Service. And we work with our customer organizations, and we charge a per year per site fee, and we provide this as part of our service. We see our solution as a platform that can be enhanced. So that the key building block of our platform is our IoT sensor, the Clarity Node S. It's solar powered, and it connects to the cellular network, of course. So it's totally independent from existing infrastructure. We don't need an available Wi-Fi network or wired network. We don't need access to power outdoors where these sensors are placed, which makes deployment very easy. And this can be deployed in a matter of minutes. And the Clarity Node S then measures PM2.5 and NO2, which are the key pollutants in cities that affect health. And also there is a good overlap between our deployment in cities where there is dense population and the availability of cellular network. So it's a good solution, makes the sensor easy to deploy. And the clarity on this can be then extended with the use of add-on modules that add monitoring capabilities, such as being able to monitor ozone, black carbon, and wind speed and direction to answer more complex pollution questions for our customers. So this is our solution very briefly. And we are seeing an impact from our sensing as a service offering. We are now deployed in more than 80 countries. And we started off with a few pilots to showcase this concept of high spatial resolution air quality monitoring. And now, today, we operate some of the biggest air quality monitoring networks across the globe, ranging from developed countries and developing countries as well. And these networks are there to serve the whole suite of different use cases and applications. So what I would like to do now very briefly is to give you a few examples of what our sensors are used for. Starting from our biggest project today is in London as part of the London program. We operate a network of more than 400 sensors. And the aim there is really to work with the city government and universities and different institutions to collect the unique data set to then generate targeted policies that are aiming at reducing exposure to pollution for the citizens. It's a very ambitious project. You should go check out on breathelondon.org, where you can see live air quality data from London. It's a very good initiative. Second use case is in Los Angeles. Is our backyard per se. Our company is based in Berkeley, California. Even though now it's actually globally distributed, we work remote. And this project is in Los Angeles. We have upwards of 200 sensors deployed at schools. So here the goal is really to inform teachers and students whether to go outside and how to basically reduce the exposure of students to harmful pollution. So it's a matter of protecting the sensitive population from pollution, especially when there is impact from wildfire smoke, which is a big problem for California. And continuing, another interesting project is in Western Australia, in Perth. And this project is sponsored by a private company, it's the Royal Automobile Club, which is an insurance company. And here, the goal of monitoring is really to drive an awareness of the link between transportation and air pollution, and also study the impact of electrification of transportation. How does that improve air quality? And then to conclude, in Kazakhstan, in Almaty, we have a network of more than 50 sensors here, and this is a place that had no air quality measurement previously. And what we are trying to do there is, together with the World Bank and the local government, is to really study the impact of clean energy transition. It's a place that uses coal for generating most of the electricity, and now they're trying to switch to cleaner forms of energy. These are just some of the examples of what we do. And now I'm looking forward to diving into the conversation. Christian.
Hey, Paulo, thanks for the introduction. Very impressive, impactful projects, which are now, as I say, always kind of changing the world, right? Changing the game. And as you initially said, you need to measure to make it visible. And we talk about pollution all the time, but basically provide the hard facts. So let's say I would start with a couple of questions, but I would also like to give the audience the possibility to ask questions. So uh, look at your GoToWebinar panel. There's a question panel, and yeah, feel free to answer any questions, which I will then give to Paolo. Or if you have questions around Amplify, you can also take some question around Amplify. But we'll kick it off with an easy one. I think a standard question in any webinar. What is kind of your biggest challenge, right? So in the industry, you also think when kind of Clarity entered the industry, what were the kind of really challenges Clarity faced?
Yes. So we saw the challenges for monitoring air quality very densely today is related to the cost and size and operation of the traditional technology. But this technology has an advantage, the traditional way of monitoring, which is that it provides very high quality and accurate measurement data. So for us, really, the challenge is how to create these lower cost devices and that are augmented by cloud, remote support from experts. But how do we make them as accurate as uh, these lab grade systems while keeping costs down and making them in a way scalable so that they can deploy them in a big number in a city. So this, in a way, we want to achieve the ease of use of the consumer and the price of the consumer device, but pro data quality and accuracy. So this is the technological challenge, and I believe we have done good work there by putting accuracy and data quality as a top priority, and by working closely with experts in the field. We do a lot of co-location studies, which is installing our sensors next to the best ones to learn about the behavioral sensors and the shortfalls and improving their performance. Um, and and this is a technology challenge. Uh, and then there is also a business challenge, right? So how can we make this, which is a very mission-driven company and project, how can we make this also viable in terms of business model? And here we came up with this innovative solution of sensing as a service, where it's not just sale of an instrument, but it's actually a comprehensive vertically integrated service, which makes the business interesting and sustainable over time. And this is where IoT really is making the difference, we feel, in enabling this sort of business model.
Cool. I can imagine it's you need to work with the governments and make sure they see the value. And change a little bit the microphone. I'm hearing that I'm maybe a little bit low on voice. So I hope you can hear me better now. Maybe can you share some pivotal moment for Clarity? Yeah. So in the beginning of the company, I know when you start off, there's a lot of things to consider, and how did you overcome it, and maybe what was kind of a great win that you did in the beginning?
Yes. So I think we were very early on in this game, or with this concept of monitoring air quality in this novel way, and we did a lot of pilots, and we created opportunity for ourselves, pitching to government agencies and trying to also get funding and organizing these pilots. Pushed very hard, and the time that was really a watershed moment for us is when we were able to win the bid for the Brit London project. I showed a slide about it earlier on. So this was it's a project that the city came up with on their own, and they really wanted a solution like the one we offer. So they have the need, right? So it feels like product market fit, and they opened this bid to different companies, and we were able to secure the contract to supply for 5 years the city with this novel monitor on a very large scale. And in a way, this was great. Okay, product market fit. There is a market for this, not only pilots, but also the um, really is the first time that our vision came to life in a way for one of the greatest cities in the world. So it was very exciting.
I can imagine the first real deployment and in an impactful environment.
Yes, I remember once I visited London later when the project was already up and running, and I went to Piccadilly Circus and was checking on the map from bridgelondon.org website, and I saw there was a sensor there, and I looked up and I actually found it next to some advertisement screens, and it was quite rewarding.
I cannot wait for that to deploy in Berlin. Yeah, so here, here there's also a lot of pollution, and I also feel I would need that to kind of get more yeah, on my bike roads, less pollution.
Yes, I think the actually that's another exciting thing about the London project is that since it was successful, now it's trying to replicate itself, and this initiative was launched called Bridge Cities, where this model is opened up to more cities, actually with a big focus in the south of the world. Uh, and we might see more of this big monitoring network coming up with us in Berlin.
Would be nice. Maybe can you give us, I mean, we're a cellular connectivity provider and we kind of help you on the way. Can you maybe give some insights? How does cellular connectivity from Amplify kind of help you in terms of efficiency and scalability?
Yes. So this is an interesting anecdote. Actually, we started with our early prototypes, and our first pilot was actually in Mexico City. So already international, right? We are based in the US, but the first project is already in Mexico. And we actually back then our early prototypes were we were trying to use LoRa, another wireless communication protocol, and we ended up noticing that we were deploying one sensor and one gateway in each location because, yeah, of course, it's a dense deployment, but maybe not that dense in a way, right? Where you can have one gateway with many nodes around it. So this wouldn't scale up. This wouldn't work. But at the same time, we were worried about one thing was power consumption because our devices are uh, solar powered. Uh, and then also, how do we do this internationally? So we started testing with cellular. We found that smart duty cycling solutions we could, and with machine to machine modems, we could actually reach our power budget targets. And then the other issue was this international deployments. And in the first times, we were actually trying to purchase SIM cards in different countries, and we had to show IDs, or maybe our customer had to build their own ID, local ID, and this was not really scalable. So then we encountered Amplify, and I think it was an immediate match for us because we solved our issues of international deployments and management of different plans, and um, also it was a good interface with our contract manufacturer to procure the SIM cards in a professional and streamlined way. And also it's provided a good APIs for us to integrate into our back office and traceability manufacturing and IoT device management system. So it was great. We immediately hit it off with Amplify, and we are still a customer, and and we are uh, and we are happy with the service.
Nice. Yeah, it's great to hear that we kind of could help you scale the solution and that you see the value. And yeah, really, yeah, I'm impressed how you scaled into more than 80 countries. And yeah, that's where you know.
Yeah, it's interesting that this is another area where we find the partnership with the Amplify Valuable when we go to new countries, right? So there is always some testing. Also, sometimes our customers are wondering how it's going to connect uh, uh, over here. Have you worked here before? And like, do we need to procure SIM cards? And we're like, no, it works out of the box. And they're like, oh, really? We have no other projects here. And then we do say that before deploying on the field, we want to test maybe in the office. And then often just it's enough to power up the device and it connects with no problems. Sometimes we do need to fiddle with it a bit more. In some countries, we did a lot of deployments in Africa, and there were a bit more challenges. But then two things were good. One is being able to already verify from the documentation website of Amplify that there is coverage with the bands that are supported by our modem in that country. And then the second thing is that even if we need to play around with it a bit, there is a dashboard, which makes it quite easy.
Cool. I would take, maybe one question, if you don't mind. Does Clarity work with satellite, right? So that was one of the first questions, which actually also goes in line with what MDFi is doing right now. But maybe Paulo, can you answer this maybe?
All right. So I guess there is two ways to interpret this question. One is, do we use satellite data to measure air quality? It's actually a field that is advancing there as well. It's a technique for monitoring air quality. It's more focused on regional measurement. It's very useful. We don't currently use that approach. We do uh, very localized measurements, maybe targeted around a specific policy. Maybe you want to close down this road, or you want to replace diesel buses with electric buses, and then you plan your deployment. So we really need this very localized and high resolution. So satellite air pollution monitoring doesn't help there, but it would be interesting in the future to include some of that data for analysis purposes. So that's one way. The other way is, do we connect to the satellite for internet, for being able to deploy our sensors in remote locations? And the answer is not currently, even though we have explored the possibility, because there is some exciting or like potentially high impact deployment scenarios where sensor would have to be in very remote areas, especially related in the US to wildfire smoke monitoring, even early detection of wildfires by detecting their smoke. So this is a very interesting use case for us, but we haven't been able to find a solution that works also in terms of cost, power budget, and complexity yet. But it is something that is on our radar, not yet on our roadmap, but it's an interesting thing to observe.
Paulo, if I'm not mistaken, you're also part of our evaluation program.
Yes, we signed up, so we really want to see how that goes and test it out.
Yeah, I'm also, I see it work here in the office, but I want to see, this new technology which just came out last year, really to see how it's deployed in the field. And yeah, looking forward on collaborating there with you.
Yeah, that could be quite a game changer, because there is big gaps of air quality monitoring data in remote locations where we have no idea of what's the situation. Of course, there is also maybe not dense population, but in some cases, there is tribal land in the US. And also there is this wildfire smoke, which is interesting to track, even maybe not directly related to exposure of people when it's in remote locations, but it's still interesting to track. So it would be an interesting offering if you can pull it off.
Okay. Hey, Paulo, maybe we do a little bit of a content change and look into kind of what are the key trends in environmental monitoring. I can see that there's a lot of regulations probably coming up, and would like to get your perspective. What are the trends and how this will affect the industry?
Yes. So in terms of regulation, we are observing that the standard of what is considered to be acceptable or good air quality are getting tighter. Actually, earlier this month, the US EPA uh, released an update to the definition of the quality index, the American Air Quality Index, that says transforms concentrations that are hard to interpret, right, for citizens into color codes and good, fair, bad, hazardous categories that are easy to interpret. So they actually um, they move the threshold that goes from good to fair lower. So they're saying basically that it's actually uh, worse than we thought in terms of health impact, and we need to have it clean and we have to have a higher bar. So we are observing this where thresholds are getting tighter. Also, WHO did something very similar a while ago with the recommendation of the quality targets. So that's one thing. Another thing is that there is new things that we are interested in tracking. For example, air toxics. Um, so other types of pollutants that were not traditionally monitored that now we want to have a higher focus on, that are now found to have impact on health. I'm talking about total volatile organic compounds. I'm talking about benzene, this type of pollutants. And of course, then there is the global warming, greenhouse gases that are now under high scrutiny, especially recently methane, because we have found that it is possibly something where we have a more direct control in terms of limiting emissions, and that does have a big impact. And this is especially around oil and gas production and distribution. That is tied to regulation in terms of how much you can emit and what type of monitoring you need to have in place. So this is a good trend, we believe. We also see in the US, especially increased collaboration between government and communities and also technology providers. So they're trying this different approach where they try to involve the community in also the monitoring of air quality to raise awareness and make actually part of the solution, which is very cool. And this is something that our cloud-based software can also help with in terms of creating maps, interactive tools. Also, a focus on environmental justice lately is being heightened. So the fact that often the communities that are more exposed to air pollution are also the more disadvantaged, maybe economically, racially. And so actually there is a lot of new funding that is going and trying to address these issues. And it is great. And then finally, there is also more regulation in terms of the data and the accuracy standards for these novel sensors that are proposing this alternative way of monitoring air quality. So before it was not regulated, do it, but there was no standards. Now we are seeing accuracy targets coming from US EPA. We see MCERT, like some certification scheme in the UK, and also a code of practice of how to use these sensors in the UK. So it's becoming part of like standard way of monitoring air quality using sensors, which is also a trend for us.
Yeah, for me, it sounds like there's a lot of standardization going on, how accurate and kind of what are the thresholds, but are there also regulations in terms of that it becomes mandatory for a city at a
To
certain size
monitor.
to monitor?
It is mandatory to monitor already. In the US, there is a Clean Air Act that makes it mandatory. In Europe, there is similar laws, but it's only mandatory using, let's say, the traditional approach. And what we hope to see is that it will also become mandatory to do so in all cities in multiple locations as we are proposing. It's not yet mandatory to do this in the new way. Yes.
Okay. And, for the future, what do you see? What is the vision, for you in the environmental monitoring, particularly in context of urban planning, for example?
Y- Um, yeah, I think so as I was saying, I think the vision is that each city should have quality monitoring in place. It's almost crazy that it's not the case already. That our cities that have we have no idea. Like we can see measurement from cities that are 50 kilometers away, but is it representative? We know that that's not right. So the future where each city has monitoring and also monitoring at a scale where you can really then maybe stop focusing on monitoring and start thinking more about the data to action, right? Drawing insight from the data and taking action. That's actually the hard part, to be honest. So we really hope that then other companies or ourselves or also research institutes, universities, uh, use this data and try to draw insights, find ways to take action that is very practical.
So is there an open community for data sharing then of these environmental measurements?
Yes, there are some um, data aggregators. For open data, one that we partner with is called OpenAQ. I suggest to check out their website. It's actually a very nice initiative. So in our case, our monitoring data is paid for by our customer organization, so it belongs to them, and it's by default it's private to the organization that does the monitoring. But then we do have a way that they can make it public very easily from within the dashboard because we do want to push for like more open data, and then gets published on. We have an open API where which we basically, for example, we feed them our data into OpenAQ that I mentioned and other open platforms. And also then there is a public map where people can explore data from the select open monitoring sites.
Cool. Yeah, I see that we here are working a lot of, how to apply AI to our internal processes, but also kind of product features. Could you maybe give some, comment a little bit on the role of AI in quality monitoring?
Mm. So for clarity, our so I was mentioning the big challenge, which is how to ensure that the data from this lower cost sensor is as accurate as the big labs that are too expensive but are very accurate and currently used by governments. So in this is a field where AI and machine learning can help. As a matter of fact, so what we usually do, and we believe is actually a good way to do it, before each project, we install all of our sensors that are going to the field next to one of these government operated expensive stations. And we acquire data for 1 month. And then with this 1 month of data, we develop calibrations for each device. So we calibrate, we tune them, and then they can move out to the field. And at this point, the data that they acquire is accurate. And this works great. Also, it's a great way to have a quantitative measure of uncertainty that is very useful for analysis. But then what we did is we have so much of this data from both the sensor and the fancy reference side paired up. So we collected a lot of this data over time. So what we did is train the machine learning models so that now we can actually ship devices that are pre-calibrated. So they work out of the box. You don't necessarily need to put that 1 month next to the government station. And this actually enables some new use cases and some new organizations that don't have access to this So it's very exciting. So that's how as a company, how we use AI in a very way.
Nice. Yeah, it's a game changer, and you have to apply it to your domain to make use. Cool.
Yes, very
Maybe last
exciting.
question. Maybe last question. A little bit more Amplify related, but how do you see the partnership between Clarity and Amplify evolving over time?
Yeah, uh, I think that as we continue deploying in new countries, we will make good use of the features that we already currently use. So I think that's going to continue. Another opportunity that we see is to maybe shorter term is to make more use of the telemetry that Amplify provides to enrich the telemetry that we already collect from our sensors. Because, when you operate networks of hundreds of sensors outdoors, sometimes the technician field intervention is actually more expensive than the year of service that they pay for that site. So we want to really reduce mistakes. So having telemetry can help remotely troubleshoot. And one thing in particular, we saw the new feature of being able to locate the device based on tower they're connected to probably. And this is very useful. We do ask our customers to mark where the device is deployed, but then we can check and do some quality control there with added information. So telemetry and reducing field interventions is great. In the midterm, we are looking into developing new add-on modules for our Clarity Node S so that we can measure more pollutants. Some of these pollutants actually require a way faster sampling. So we are looking into ways to upload more data compared to what we do right now. So maybe more bandwidth, but still cost effective. So that's something interesting. And then long term, there is this, what we'd already touched on earlier, is this huge swath of area where there is no data at all, which are these remote locations where there is interest in monitoring as well. So a satellite solution would be really interesting long term there to cover up these holes in our understanding of air pollution.
Cool. Okay, Paolo, with that, I would open it up to more the questions of the audience. So please feel free to ask questions in the question panel. And you have here the industry expert and can learn from Clarity. Maybe while we wait for the questions, I have another one, like kind of for the remote management of the IoT devices, right? You also already mentioned that once the sensors are deployed, it's kind of someone going there is more cost than the lifetime
Yes.
of the device the device itself. So how do you support kind of remote management? What are your capabilities?
Yes. So that's actually one of the responsibilities of our Clarity Cloud. We offer this dashboard, which is Clarity Dashboard, where the user has a kind of 1,000-feet view of their monitoring network. They get a summary of device status, including signal strength, but also battery levels, error codes, or alarms, whether a sensor is malfunctioning or other issues that we can deduct from the telemetry that our devices upload. And this is actually one of the. I remember at the beginning when we started with our MVP or like minimized version of our product, it was the most requested feature to have more device status to do troubleshooting. So we developed that quite a bit, and it's actually one of the key differentiators for us is what allows Brit London to manage a network 450 sensors with a few people. And it's very important. Um, then, yeah, so I think that's what we do there. Then there is this alarms that you can also get via email. We also have roles in our dashboard that it's a technician role that is mainly focused on keeping the sensors up and running. And then we have an analyst role that is more focused on later on reviewing the data, visualizing the data. So with this role and perspective, we can provide focused information. And this has been good as well to address this.
Maybe here one question that goes in the direction what also kind of is at the heart of Amplify, right? So we always take pride in integrating in other solutions so that it becomes easy to use our solution. Maybe can you give some insights about how Clarity's solution can be customized and integrated in other systems?
Oh, yeah. So that's actually very important for us because many of our customers already have, especially when we work with government agencies, they already have their, say, data management system for environmental data. So it's important that we are able to plug in the system. And so that in that case, the dashboard becomes more of the operational tool for the network. And then the data visualization and analysis is done more on their existing platform. So we have an API, both for historical and real-time data, but also device telemetry status. But everything you can see in dashboard is also the API. We have this API first approach where we use our own, the API we offer to our users, the same that we use ourselves to build out the product. So it's like eat your own dog food mindset. Yeah. And then this is, so this is important. It's used a lot by our customers.
Okay, maybe one last question is, how do you ensure the accuracy, right? So you dove into it already before, kind of how important accurate measurements are. So how do you ensure the accuracy and the precision of the air quality?
Yes. So this is actually, this, I cannot stress how important this is because it's the foundation of everything. Once you do measurement, you want it to be really representing the truth and you want it very accurate, especially if you're basing on it decisions that might impact health and policies. Very important. There are, sensors you can buy online on Amazon that show you the air quality in your room or also outdoors. But for the type of work we do, we need to go beyond that and really make sure that we have accuracy spot on. So then our process starts all the way at the factory, right? Until the calibration that I mentioned, where we, before field deployment, we install the sensors right next to a government monitor for 1 month. And we tune the sensors based on how they respond. And this is done locally. It's like next to where they're going to be deployed because it really matters to tune them in the environment where they're actually going to operate. There is a lot of impact of environmental factors like temperature, humidity changes, and viewpoint. And composition of the aerosols or particulate matter. So it's really important to do locally. Machine learning and AI helping us now, but still, it's important to do good calibration. And then ongoing data QC. What we do is, for example, we always keep one of our sensors permanently co-located, which is installed right next to the government station over time. And we use that to monitor for drift and eventually run another calibration later on. And these are some of the steps we take to ensure accuracy.
Cool. Paulo, it was really a pleasure having you. I can see that you're kind of purpose driven and, want to make your solution count and that, as you said, change the world. Thanks for giving us some insights here, how the solution looks like and how you benefit. Also from our Amplify here. Thanks for the good words, and yeah, hope to talk to you soon. And I hope that the attendees also could take away a little bit here about the industry and this. Thanks, Paulo.
Thanks so much, Christian. It was a pleasure, and thanks for having me.
Cool.